I am Ayushi Tiwari, working as an associate software engineer at Red Hat, and I am delighted to be here today to share my insights into how we are rethinking diagnostics in the Linux environment. So the title of this session is From Debugging to Prevention, Smarter Linux Diagnostics with the Automation, and the heart of this transformation is a powerful open source framework, InsightScore. So in this talk, we'll explore about how InsightScore enable us to go beyond traditional debugging approaches and move forward towards more scalable and proactive approaches which do not involve human intervention and solve the issue before they even escalate. So let's start by understanding the foundation of this diagnostic system, InsightScore. It is a Python-based open source framework developed for analyzing Linux system data, and at its core, it is a data collection and analysis framework built for rapid development, which includes robust set of reusable components to gather system data like logs, command output, config files, and one of the most strength of InsightScore lies in its object model. That is, it converts unstructured and semi-structured data into structured Python objects, which makes rule analysis and diagnostics more efficient and powerful. So now we have seen what InsightScore is, but the natural question arises is why to choose it? What makes this framework stand out? So other than its transparent nature, we'll be looking at two of the most critical advantages which InsightScore provide, that is its support for reactive as well as proactive issue detection and prevention. So in reactive, we basically see that team responds reactively when something goes wrong in the Linux environment, such as any services gets failed or any issue is occurred. So after that, we'll be solving it. But till that time, the downtime has already occurred, and it might be possible that we'll have to digging through all the log commands and running all the ad hoc shell commands and shifting through the configuration files. So, but with the help of InsightScore, this process gets more structured and powerful. How? It simplifies the post-incident troubleshooting by the data collection and automating the analysis of logs and command outputs, and it converts the unstructured data into more structured Python objects. And other than this, one of the most important feature of InsightScore is that it allows you to write your own custom rules, your parsers, combiners, you can write as per your requirements also. And now, but other than the nature of reactive support only, InsightScore helps you to support proactive preventions also, like with the continuous monitoring occurring at the same place, which will help to detect early warning signs before the issue actually happens. And it will, other than the debugging and detection, it seamlessly supports integration with the automation scripts or any automation tool to fix the issue without any human intervention. And it helps to prevent the downtime of the system and also improves the system stability and ongoing health checks, which is also like a continuously system health checks also. Now we have seen what InsightScore and its feature, but how does it provide all these capabilities? So these are the components which we'll be seeing, and all the components plays a crucial role in the entire pipeline from the data collection process to providing an actionable insight. So the first step is collection of the data. So tools like Insights Client or source reports are used for the collection of the data in the format of any compressed archive. So this makes sure that yes, we have the raw material ready for the analysis process. And now we have our unstructured and raw data ready. So specs are which defines the instructions that this is the source of the data which I actually need. So think of them like a blueprint. So specs will tell the framework that this is the path of the data which I actually need. For an example, we want to check the log which is present in the messages file, but we don't know the exact path. So specs will be telling us that yes, it is present in the varlog message directory. And now parser comes with, so now we have the data ready, we need to interpret it. So parser will convert these unstructured data into structured Python objects, and a good parser will encapsulate all the data into all its content into reusable and testable way, whether the data is in the format of any key value pair, a structured JSON objects. So parser will provide its output. And combiners, what happens that there are some times when parser does not give you the full picture of the details of the system state, but that's where combiner comes in. It combines all the multiple parser outputs to provide more higher level context. For an example, there is a parser which is telling us about the operating system version, and there another parser which is telling you details about the kernel details. So individually these both parsers are giving us isolated facts, but when we combine them both, then yes, this will be telling us, consider like this is a Fedora machine running on kernel version XYZ. So after parsers and combiners, the main thing comes, that is rules. So rules are where actually the business codes are written in the Python objects. So parsers and combiners act as an input for the rules. So they will be written in the parse and combine data to detect the issue and provide an actionable insights. Other than this, there are some features which Insights Core provide, that it is more than 200 Linux parser. It provides that if you want to check for any kernel details or any metadata details, so there is a probability or possibility that yes, there is already a parser written for that, and you don't have to start everything from the very scratch. And it supports wider range of Python version. So that is very efficient for the organizations maintaining newer as well as older versions also. Next is, you don't need any external support for starting the Insights Core. It provides you built-in support for the data collection from the local host only, and you don't need any external environment to start Insights Core process. Other than this, it provides you support for multiple archives. So if you ingest data in the format of any source archive or any tar file, so Insights Core has the capability to ingest the data and parse the data against it. So now, how does reactive troubleshooting actually takes place with the help of source and in the Linux system? So first of all, let's understand what is source. It is an open source community driven platform or for collection of the system logs and debug all the information. So basically it collects all the data into a proper archive format. So that archive is known as source reports. So it collects the logs, your config file, service status, and all the information of the system into a single archive. So this is basically, the size of the source is large. So source also provides you feature for plugins also, like if you want to get the details for networking only or storage only, so source helps you to provide you various plugins also. Now how to generate source basically. So you can simply install it using any standard package manager using yum or dnf in your system, and once it is installed, you can use this command sudo source report, and this command will collect all the diagnostics and all the configuration information of your system into a proper compressed archive format. So that archive is source report, and by default it is saved in var temp directory. But yeah, you can change it as per your requirement also, and the file of the name of the file is saved with host name as well as timestamp for easier identification. Now, how does actual troubleshooting takes place? So we have a Linux system data, consider RHEL or any Fedora as on any system. So if any issue is detected in the system, then for the first step is basically to generate the archive for that. So source reports will be generated, and this will be acting as an input to the Insights Core rules. So once we have the data collected ready in the Insights Core rule will check against the archive, and if it detects any issue, apply all the rules and extract the important facts for it. And after that it will produce a rule based diagnostics or results. So like if any issue is detected, so it will provide you like if error is detected or any warning is detected. Now we have seen that once the issue has been done, then we are solving the issue. But what if we can solve it before they even escalate? So here comes, we need to switch from reactive debugging to proactive prevention. Proactive prevention basically means identifying the misconfigurations the moment they appear and spotting the patterns based on the historical data. As well as we can also integrate automations and use automation scripts and tools also with this. So what is the basic need to shift from debugging to prevention? So debugging is inherently very time consuming, and we are often racing against the clock. The issue has occurred, we are just finding the logs and commands, and often happens when after the damage is actually done. But preventive analysis flips that model. You can detect the issue earlier and before the failures actually occurs, and it also leads to reducing the downtime and improving the higher system reliability. Other than this, automation enables faster resolution without any human intervention. So this is the end-to-end workflow for proactive issue diagnostics and remediation with Insight Score. So first of all, a cron job is there, which is used for collection of the data in any archive format, and after 5 minutes, once the archive is collected, there is another second cron job that will kick in, an automated analysis trigger will happen. So this will be working against the latest source archive or any archive that is in the latest format. So Insight Score will be running against it, and data extraction and rule execution will take place. And if it detects any issue, then it will be logging it in any JSON file for the record purpose and for future use also. And if after the logging the issue, it will send the notification directly to the user in which the issue has been detected, and it will, if there is any automated remediation step is there, so it will be detected, it will automatically solve the issue. So this cron job actually takes place, it can be done once in a day for the system health check, that is more than enough. So to understand it, let's see one of the use case where a background service is running and leaking memory over time, eventually leading to killing the processes with out of memory errors. Initially the user will not understand it, but there might be possibility that a system slowness might take place and eventually lead to full crash, which might require a rebooting of the service. So the user doesn't notice it until the system actually freezes. So let's try to solve this issue with the help of proactive insights. So we have a collect archive sh bash script, which will be collecting the archive, which will be creating an archive for us, and run analysis is the core part where actually code takes place, where it will be running against the latest Insight Score. And notifier it's a Python file for sending the notification to the user via email or any console alert, and rules are where the actual Insight Score rules are written. And remediation is the bash script, which is written for automated remediations or restarting or any service of any issue which we have detected. So how Insight Score actually helps? So you can use source reports also, but for the demo purpose, since the size of the source was large, I have used a basic bash script for generating a tar file. So this will be generating a file in the archive file for memory and as well as the process running in the state. So once an archive is generated, again a second cron job will kick in, and it will be starting the process run analysis.py file. So this is the main file where actual process takes place. It will be finding the latest archive and load the extracted data and run against the Insight Score rules. So since Insight Score provides you features to write your own custom rules also, so you can write as per your requirement, but here the use case was finding the memory leak. So I will be showing you the rule in the next slide. So it will be finding if any issue is detected, then it will log it in the JSON file and send the notification to the user via email or any console alert. So, and also trigger the automated remediation step. For an example, we can restart the service, or we can, and also enable. So this is the perfect example of self-healing and self-diagnostics, and which enables a continuous automated and proactive monitoring and fixing. So this is one of the examples of how rule is look alike in Insights. I have imported rule decorator, which is in the Insight Score, and meminfo is the parser for checking the memory availability, and psaux is the parser for checking the process which is in the running state in the system. So the core goal is basically to check the process which is taking more more space. So, and other than this, if there is any less memory, less than 100 MB. So, yeah, so it will be checking if there is memory lesser than 100 MB and any process which is taking more than 50% space. And if there is any issue detected, then it will be resulting that yeah, a memory leak is suspected in this process. And logging and notification. So yeah, there are two functions, log issue and send email. Log issue will be logging all the issues in the JSON file in the dictionary format for the timestamp, rule ID, and all the message will be like what is the issue detected basically, and it will be def send mail is the function basically for sending the it's like a placeholder for sending emails to the user. So yeah, I have just written the automated remediation script like basic bash script for running, restarting the service which is actually leading to memory leak. And this was one of the example, but other than this, Insights Core also provides you some other real world use cases like systemd services. So this is basically for system management and it can auto detect and recover all the SSHD failures or HTTPD crash is occurring in the system. Kernel and performance are the silent disruptors which can gradually harm your environment. So with the help of this proactive detection, we can flag the national interface card resets or DNS issues or any packet loss which might affect the user. Memory, we have seen one of the examples of out of memory kill error issue, and it will detect all these errors also. Security, it's not just about firewalls only. It can alert your system like SSH config errors or TLS or SSL certificate issues are occurring in the system. But the user impact is none. We don't have to do any click or we don't have to write any code to solve the issue, and issue is predicted and fixed silently. So what are the best practices for the proactive automation? First of all, keep your rules very lightweight, avoid writing very over complex rule to which takes much of your resources in the systems, and write very modular rule design. So you can write your own custom parsers, combiners and rules. So just write which are more modular, like which can be reusable and in the maintainable format, and always validate your rules with the real data. To you can validate the rules against any historical or live data so that it does not provide you any false positive hits. And schedule regular data collection, like for proactive issue detection we have to set up a cron job or any systemd timer which will collect our system state in the format of any archive. And always focus on high impact risk first, that write automation scripts for only for those issues like which are recurring again and again, and log all the detected issues in any JSON file or as per your requirement for solving the issue. And last is customize it according to your environment, according to your requirements also. So yeah, don't wait to debug, prevent it. And Insights Core is open to contribute also, and if you want to use it in your projects, you can just you can just check it out and use it also. And if you want to contribute to any parsers, combiners or any rules, so yeah, Insights Core is open to contribute also. Can I switch? Okay, yeah, you can connect with me on LinkedIn just by scanning the code. Thank you so much. Any questions? Okay. Yes, please. Could you please repeat? Yeah, data collection by? Only for? It's not like, yeah. Could you, so like data collection is, you are asking that it's time based. Yes, and then asking also that there are plans to make it event driven. So I don't know about like what are the plans for it, but yeah, it's not whatever the issue at that instance only. So archive is collected on that instance. So yeah, it is time driven only, but I am not so sure about the plans which will be like event driven or not. Okay, yeah. Yeah, thank you.